Good morning all of you. I am Tanushri Dalai from Civil Engineering branch and today I am going to teach you your Theory 2 paper which name is Structural Design 2. So in the last class we discussed about the procedure of tubular section and how to design the compression member as well as the tension member in case of truss and compression member for only compression in tubular section. So now we will do a numerical based on tubular column. So let's see what will be your question. So the question says a tubular section, that is a column type of section, consists of IS 1161 grade, YST 32 steel. The column is hinged at both the ends. The outer diameter of the tube is given as 219.1 mm. The weight of the column per 1 meter length is given as 310 Newton. The length of the column is 4.5 meter. Determine the safe load carrying capacity of the column. So according to the procedure, we will solve this problem. So first of all, in step 1, according to the IS code 1161-2014, size and property of the section we have to write down. So according to the question, outside diameter of the tube is given as 219.1 mm. Weight per meter is given as 310 Newton. So area of the cross section we can find out from the code 1161-2014. Hence, the area is given in the steel table is equal to 39.52 centimeter square, which is equal to 39.52 into 100 mm square. So this is the value already given in the IS code. Then the grade of the steel in column section given as YST 32. According to this, we will solve this problem. So length of the column is given as 4.5 meter, that is 4.5 into 1000 mm, and radius of gyration we can find out from the steel table as 7.54 centimeter, that is equal to 75.4 mm. Next is your step 2, where we need to calculate the slenderness ratio of the column. So we know that the slenderness ratio of the column is equal to effective length divided by radius of gyration. Hence, according to the end condition which is already given in the question, that is, the column is hinged at both the ends. So whenever the column is hinged at both the ends, the effective length is equal to the actual length. So that's why here L by R we can put in place of L is equal to the actual length value, that is given as 4.5 into 1000 mm divided by radius of gyration from the steel core is equal to 75.4. By calculating this value, we can find out the slenderness ratio as 59.68. Then next one is your step 3. Here the permissible stress in compression as per the Act 06 1968 code, table number 2, we can find out the value of Fc as per the slenderness ratio. So here in case of table 2, direct value of 59.68 is not given. So we can see the table. So here you can see the given grade of the steel is this one, and the slenderness ratio that we have, this is lies in between 50 and 60. So that's why we need here the interpolation method in between 50 and 60. So for the 50, the value of Fc is given as 1539, and for the value of slenderness ratio 60, the value of Fc for this grade is given as 1468. So by the interpolation method, we can find out the slenderness ratio for the 59.68 value for the Fc. Hence, here we can put for the 50, 1539, and for the 60, 1468, which is already given in the table number 2. So by the method of interpolation, we can provide it here Fc is equal to y1 plus x minus x1 divided by x2 minus x1 multiplied by y2 minus y1. This is the method of interpolation and formula for interpolation method. So here 50 is x1, 60 is x2, 1539 is y1, 1468 is y2, and this 59.68 is your x value, which is Fc value. So now we can find out the value of Fc for 59.68 value. So put the value here. So y1 is your 1539, x is your 59.68, x1 is your 50, x2 is your 60, x1 is your 50, then y2 is your 1468 and y1 is your 1539. So by calculating all these things, we will get the value of Fc as 1470.27 kgf per centimeter square. So in place of table number 2, the Fc value is given as kgf per centimeter square unit. So we have to change this unit into Newton per mm square. So for that, we need to multiply 9.81 divided by 100. Hence, the net value of Fc is calculated as 144.23 Newton per mm square. So hence, Fc value is calculated as 144.23 Newton per mm square. So now, in step 4, we can calculate the safe load carrying capacity, which is denoted as P. Hence, P is equal to permissible stress multiplied by area. So we know that permissible stress, that is Fc value for slenderness ratio of 59.68 is equal to 144.23, and area is find out as 39.52 into 100 mm square. So by multiplying these two factors, we can find out the load carrying capacity of the tubular section. Hence, we will put the value of FC as 144.23 and area as 39.52 into 100. Hence the value is 56,996.96 Newton, and by converting this Newton into kilonewton we have 569.9 kilonewton. So in this way we solved this numerical. So today this much. Thank you.